He is
Sir, even yesterday's paper also doubts were there.
Sir, some mistakes are there for yesterday's paper.
or yesterday's paper. Yesterday's paper also you can send. And today, first of all, I want to discuss what he is asking for. Yesterday's that concept.
Two-dimensional
Yes.
rotation, sir.
I think
Omega 1 and omega
not this
2
one,
both
not
are
this
sir.
one, not this
These are-
one. This one is.
This one, sir.
Yes, now
Yes,
you
sir.
tell.
Yes, sir.
See what is happening here. We have taken along minus r cap. Yes, right. We have taken along minus r cap. Now tell me what is your doubt in this. Can you see this laser pointer? We have taken along minus r cap. It is true because it is pointing towards the center. Because the direction of omega that I had chosen, that was in this direction. So if I use right hand thumb rule, then it will be along the axis. But there are two directions possible for the axis. One direction is, could it be radially outwards or it could be radially inwards? Because axis is, first of all, it will be along axis, right or not? Omega will be along axis. Is it right or not?
Sir.
Nilkanta.
Yes, sir.
If omega is along
Yes, sir.
axis, out of two directions I have to choose. One I can choose along minus r cap,
Yes, sir.
or I can choose along plus r cap. Right? Now, which direction is it really lying?
Right,
Is
sir.
it lying along minus r cap or plus r cap? That depends how we are rotating it. We are rotating it in this way. We are rotating in
Yes,
this
sir.
way. As a result, we know that omega must be, if I take my right hand fingers and I point in the direction of the rotation, then thumb will be pointing in which direction? Thumb will be pointing in this direction.
Leftwards, sir.
Leftwards.
These
sir.
are my fingers.
Okay, sir. Understood.
And this is the direction of thumb.
Right hand
Something
thumb.
like this means I am not able to draw
Yes, sir,
properly,
thumb
but
rule,
you
sir.
understand. Right hand thumb rule. Okay.
Understood.
Is that
Understood.
okay?
Yes, sir.
Right.
Sir, even yesterday's question paper.
Sir, I sent you
Yesterday's
in
question
Gmail.
paper also you can ask.
Sir.
Yes, sir. Once open it.
Sir, I sent you in Gmail, sir.
Okay, good. I will check from Gmail then.
Sir, I have a doubt in this problem.
Hafiz is having doubt itself.
I am not able to understand. You are asking doubts.
Sir, yesterday's concept on doubt.
Who is talking about in between?
Previous question only, sir. Now you should know, sir, that one.
Someone is talking in between. Please mute him.
Dheeraj,
Dheeraj Reddy, sir.
Dheeraj Reddy, just remove him or mute him. Do something. So this was the question paper which you are asking, right?
yes, sir. Yesterday's paper.
Yes, sir. Yesterday's paper, sir.
Yes. Tell me what is the doubt. First, you tell me that question.
Come from the starting.
Starting from. Okay. Okay. Wait a second. Let me. Yeah.
From here only, sir.
Wait a second. I want to discuss the papers in this paper discussions. Yes, here I will discuss now. Now you tell me. Question number starting from 26. Yes, say. 27, 28, 29, 30, 31, 32, 33.
Sir, in 32, sir, 32, sir, 32.
32.
Yes.
Or we are getting option 1, sir.
Sir, it is option A, sir. They have given option B.
Let me check. Two spheres of mass m each, moving with velocity u, moving in directions 30 degrees south of east and 30 degrees north of east, respectively, collide at a point O and stick to each other. Okay, they are sticking to each other. Are you noticing it? They are sticking to each other. So
Yes,
it means
sir,
it is not
sticking to
direction.
each
other.
E equals to
Let's go.
E is equal to
E is equal to not only equal to 0. Equal to 0.
They will move with common velocity, sir.
Sticking just frictionless surfaces. This is different case, and when they are just sticking together, then it is a different case.
Different case, yes, sir.
Yes, sir.
Momentum conservation.
Okay. Then momentum conservation only.
Yes,
You
sir,
don't
we
need to
can
worry
do.
about any line of effect or any other
Yes,
direction.
sir.
Just direct momentum of conversion.
No
We can write
value
m
of
into
doubt, sir. Just check direction, sir.
direction. Let me check once. U is moving in which direction? 30 degrees south of east. East, north, south. 30 degrees south of east means 30 degree from here.
Yes,
this
sir.
way. And 30 degree north of east. North of east means
Yes,
this
sir.
side, 30 degree north of east. Let us, both are m only.
M only, sir. Equal mass.
M only. Then u and u. Then momentum will be m into u cos 30 plus m into u cos 30. So it will
That is the mu root 3, sir.
mu root 3, sir.
cos
mu root 3, sir.
east. Then velocity will be divided by mass. So velocity
Yeah,
will be, I
sir.
think, u cos 30.
Mu root 3 by 2 due east. Option 1, sir.
Option 1, sir.
Yes.
Sir, how will
yes,
they
yes,
collide,
yes.
sir?
Right.
After the given root
However,
3
they
by
will be
2 next,
colliding.
sir.
Sir,
Why?
Sir, in the E-Pragna, they give answer in east only, sir, but option is 4 given, sir. Key
Yes,
mistake, sir.
Key mistakes.
Only key mistake, sir.
Only key mistake. Okay, fine then.
Yes,
Fine.
sir. And the
you are
solution.
also
We got correct only, sir.
We got correct only, sir.
okay. Then fine.
Yes, sir.
But some boy is saying, he is asking another thing. He is saying how they are colliding.
Someone has
This is going this
asking.
side and this is. Can they collide? I think they can collide. See, imagine one is going this side and from this side, and when they will reach at the intersection point, then they can stick together, no, and they can move.
Sir, how they collide is yes, sir, like this. From different points they can get.
Like this, it is
And they
going this
collide
side,
and
Yes,
stick
sir.
in same
and
direction.
at the intersection point, they can move in one direction. Then,
Yes, sir.
okay.
okay, sir.
Question number 33,
No doubt.
34,
No doubt, sir.
No doubt, sir.
35, 36,
No doubt, sir.
37, 8,
Page up.
Sir,
40.
screen is not moving, sir.
Screen not.
Screen not
Yes, sir. No, it's okay.
41, sir.
Sir, once
Now moving.
previous page. Sir,
41.
35 option 3 is 1 by 20 root over GL is coming, sir.
Sir, that
Okay, let me
option's
check.
wrong, sir.
35.
Option is wrong. Which answer should be the correct answer?
Actually, sir,
3, 4 is the
BGL
2 are
by
wrong
2.
option, sir.
Sir, BCD 3 are wrong only, sir.
Yes, sir.
Three are
BCD
wrong.
3 are
Three wrong.
wrong. Yes,
3
sir.
are wrong
2,
only,
3, 4. 2, 3, 4. They are 3 are wrong.
They are
sir.
asking. Oh, then they should have asked which is correct. I think.
Statement.
Yes, sir.
Yes, sir.
Then answer will be 1.
No, sir.
Yes, sir.
What answer they have given?
4 is given, sir.
Means, it is in material, sir. A printing mistake, sir.
Printing mistake. Yes, sir.
Printing
Then
should
leave it,
come
leave it.
out
You
and
know
there
already.
also 2 should come out, sir.
Then you already know about it. Then it is good. You already know. Then no need to discuss. I think you are same thing only.
Yes, sir.
Material,
Same
fine.
thing.
This boy who is asking, you are
Yes,
satisfied?
sir.
Okay, then 36.
Physics, no doubts.
No
Screen is
doubt,
moving or
sir.
not?
Moving, sir. No, it's
37,
okay.
38.
No. Sir, one
Sir.
cell 37, sir.
37.
37, sir.
37. Okay. A ball of mass m. A ball of mass m is dropped from certain height and strikes a wedge kept on smooth horizontal surface and moves horizontally just after the impact as shown in the figure. Okay. If the ball strikes the ground at a distance d from the initial line of the fall, determine the amplitude of oscillation of the wedge after being hit by the ball. So from what height it is falling?
Height.
H height. What
H,
is
sir.
Right.
M or capital M?
Small m. And is there elastic collision information given or not?
No, sir.
No, sir.
I think elastic only, sir. It is.
I think otherwise we cannot solve. I am
Yes, sir.
assuming elastic. Although it is
Elastic
missing in
only,
the
sir.
question, they should have mentioned elastic or not. If I assume it to be elastic, then I know one thing. Then again we have a problem.
What?
What problem we have? Okay, no. Okay, let us see. Then I think it will be solved. No problem. Let us check once. Then I know it has, let us say, velocity. It acquires velocity b backwards. Let us say, if it acquires b backwards velocity, then I can say that there will be one velocity this side. That will be equal to, what is this angle with the normal this side, theta, 91 theta again. This, if the ball strikes and moves horizontally. So it is coming with what speed? It's coming with u. And going with what speed along tangent? Along tangent, it will be
Sin theta.
component of u in this direction, which is u sin
U
theta.
sin theta, sir.
That is u tau. And but along perpendicular, if I have to say now, along perpendicular, let it be backwards velocity Vn. So the component of V in this direction, we already know, I think, that
Along
theta,
line.
so this will become 90 minus theta along the perpendicular line. Along the line of
Sir.
impact, along the perpendicular
Yes,
line.
sir.
So it will be V sin theta. So what is the relative velocity of separation? Relative velocity of separation, Vn because of the ball and V sin theta because of wedge. So
total Vm plus V sin theta. Sir,
Sir,
Sir, sir.
your voice is breaking, sir.
cannot see what you're writing also, sir.
Sir,
Sir, voice was breaking.
voice was not there. Sir,
okay, I will try. Wait a second. बेटा ये मेरी क्लास में अभी क्लास है बाद में. Now I am sitting right in front of router only. It should be okay.
yes, sir, no, it's,
It is okay now.
Yes, sir. Okay,
yes,
sir.
sir, it's audible, sir.
Okay then.
Audible.
Then it is where was I? I was in this space. Vn plus V sin theta is equal to U cos theta, right? Because velocity of approach, it is theta angle, velocity at which it was approaching U. This is, I think, theta angle. Then it will be U cos theta, right?
You cost
So
it, yes, sir.
one equation we are having this one, and another thing we are having that along the vertical the component of velocity should become 0. This also we are having vertical component should become 0 because finally it is just moving along horizontal only. So vertical component should become just 0. Although see, I'm being suspicious. It may be not right actually here, but if I do it, by energy conservation it can be done. I think much easier way. See this way. mgh potential energy. This we don't need also. I was doing it, but no need. I think so. We can do it in this way directly. mgh is equal to. Let us say it acquires p momentum this side. It will acquire p momentum back side because both here are horizontal. So I can write p square by 2 mu also quickly. So I can get the value of p from there. And finally, that only from here I will get the momentum p. After getting momentum p, I can write p square by 2 capital M. That is the kinetic energy of the second one. And that will convert into half of k x square. So I can get x from here. Right?
Okay, sir.
So I think
Yes,
first
sir.
question, I will tell you not to find out p also. Why? Because you can just take the ratio of 1 with the 2. Then p square
Yes,
will
sir.
get cancelled out. Then
Cancel
we are
it.
directly getting x from there. Right?
Yes, sir.
But that does not involve D, no, sir.
Which does not involve what?
There in we can say that X is in terms of D.
X. What is x?
X is this compression, sir.
Compression.
Compression is the
Okay,
if we take
this x, sorry, this x, yes, this is in terms of
D also there, no, sir. D.
what is D?
In the diagram they mentioned D.
Ball strikes the ground at a distance d from its initial line of. No, why will it depend on D also?
Sir, we can take delta P horizontal is 0, no, sir.
Okay, I understood what you are saying. Yes, we can get answer in D terms also. So we can get answer in terms of H, but answer is given in terms of H. I'm noticing this thing. No, D is also given, right?
E and H both together,
Yes, sir.
sir.
Okay.
We
Then
can
I will
take
do one more thing here. Then P by
horizontal
M. P
momentum.
P by M. H is what height here? H is the height from which it is falling, or H is the height?
H is the height from it from after collisions.
I think H is this height below height, right? This height is H.
Yes, sir. Yes, sir.
Then what I did is not right. That was if it is falling from height H. It is not falling from height H. It is striking at height H. If it is striking at height H, then I will do like this now. Then I will do this only. P divided by M will be the horizontal component of velocity. Horizontal component of velocity into root 2 H by G. Horizontal component of velocity into root 2 H by G will be equal to the horizontal distance covered D.
D.
One equation. Another equation is that P square by 2M is equal to half K X
Half K X square.
Then I will use this, and UH I can write in terms of P. Then I will be getting this thing. I think you can do now. Can you do?
Can do, sir.
Yes, sir.
Very good. I was actually what I was answering this question. If it is falling from h height, then the potential energy loss will be mgh, and that will convert it into the momentum P and P this side, momentum of the ball in left hand side and momentum of the wedge in the right hand side. I was taking that case, but it is not that. I think now you told me that this is not the height from the above; it is height from the below, at the point at which it strikes. So it is this height here. We don't know from where it was coming. Then I should do in this one. Okay.
Okay, sir.
Okay, sir.
Question number 38.
Okay, so understood.
41,
49.
sir.
No doubts.
41. Okay. This boys, I think somebody asked this yesterday also, and see, it was simple.
Same.
Exactly, sir.
Done,
This
sir.
is just, see here, what force will be acting now? It is coming with v velocity down. It is going up with v velocity. But I told you, whenever we solve such question, we will take some observer in the frame of this system. This is observer here. With respect to the observer, this will be at rest. Chain is at rest. If chain is at rest, then the dm particle, which will be now entering into it, that dm particle will have what velocity? It will have velocity v downwards. Although dm was at rest here, these particles were at rest. But with respect to our chain, dm has velocity in which direction? Downward direction. Is it right or
Yes,
not?
sir.
Yes, sir.
Yes, sir.
And rho v square.
Before entering the chain, it has v downwards, and afterwards it enters the chain. And when it enters the chain, then velocity becomes v to 0.
Yes, sir.
Okay, 0 means because it acquires the same velocity as that of this person, so its velocity becomes 0. So what force it should apply? It is like in our system of this chain, some particles are being hit, dm particles are being hit with velocity v, and finally they are coming to rest. Think like that. Then what force it should apply? It should apply force lambda v square downwards on this chain. On this chain, what force will be acting?
Yes,
Lambda v square
The
downwards.
lambda is rho
Or
there.
we can think in another way. We can think in another way also. If you are not understanding this, you can take this as a system. If I take this as a system, then I can say on this system, how much particle is being ejected? dm particle is being ejected. With what velocity it is being ejected? With v velocity it is being
With
ejected.
v velocity.
Yes, sir.
If it is being ejected with v velocity, then on this particle which was on the ground, this system was on the ground, on that what force will be acting now? Because it is being ejected, then force will be in opposite direction, lambda v square.
Yes, sir.
So understand that on this it is downwards, on this it is down, on this when it is being ejected with v velocity upwards, then the force acting is downwards.
Yes, sir.
And if that is true, then the force acting on the red part should be upwards, because these are action-reaction pairs. On one it is downwards, on other it will be upwards. Understood?
Yes, sir.
Yes, sir.
No, wait, did I do something wrong here? Wait, what is it happening here? Rejected in upward direction, and then force acting downwards. No, something wrong I will tell you. What did I say? dm,
It will be upward.
how the force will be on this side here? dm part, from here the mass is being subtracted. It is being rejected from it. If it is being rejected, with what velocity it is being rejected? It is being rejected with v velocity.
V velocity.
And no, wait, I understood what is wrong here. In this analysis, there's a problem. I cannot do that. Reason is, see what is happening here. If I do this way, then there is extra force is also acting T. I am not taking that into account. Okay, some thrust force is acting, that is true, but let me think again. Wait, let me think once again on this. This is dm, and on this dm, what velocity it is acquiring? These particles are acquiring velocity v. Then what should be the force acting on it? That will be backward force downwards, and which is equal to lambda into v square. But now there is one force upwards, that is equal to T.
Yes, so lambda v square downwards also.
Lambda v square is downwards.
Rho g into h minus y also will be downwards also, due to gravity.
Rho g h v will be also be downwards, right? That will also be
So
downwards.
total force will be downward force only now. So sum of both thrust force and gravity.
Force and that one.
So yes, lambda. Wait a second. Let me take here again. Lambda v square is downwards. That is correct.
Yes,
What
sir.
force is downwards?
Rho g into
Another
h
force
minus y.
Minus y.
Lambda into
That one is lambda is rho over here.
lambda is both. This lambda into h into g.
Yes, sir.
That and right hand side it is lambda into y into g.
Y, yes, sir.
Minus
Lambda yg.
Plus
Lambda
t is
h,
equals to lambda hg plus rho v square.
then our diagram, our net equation becomes like this here. See, one force onwards P, another force onwards lambda yg,
Ig.
and left hand side lambda hg, and the one more force lambda v square.
V square, yes sir.
So
Balancing we can get.
these are balanced both sides, and what do we get? P plus lambda yg is equal to lambda hg
V square plus lambda V square.
v square. Then what we are getting from here? We are getting the value of
Equals to
P
We
is
get
equal
option
to
1,
lambda
sir.
v square plus lambda
twice.
into h minus
A
y
into H minus Y.
g. That is what we are getting, right?
Option 1, yes sir.
That is what we are getting.
Yes,
So it is
sir.
correct only,
Understood, sir.
Correct only, sir.
right? Next. Question number 42,
Sir, those are not
32 models.
43, 4, 5,
sir.
6, 7,
No doubts.
No doubt.
8, 9,
No
10.
doubt.
48, sir,
Sir,
48.
Somebody is
40,
asking 48.
yes.
48. This is a particle of mass m strikes a smooth stationary wedge of mass m with velocity v naught at an angle theta with the horizontal. If the collision is perfectly inelastic collision, then change in kinetic energy of m plus m in the collision is okay. It is perfectly inelastic means
They both move together later.
Both move
it will strike with it and it will
Stick
come
this,
to
sir.
stick. It will stick to it. So
long line of
let us say
impact.
it has velocity v. If it has velocity v, then
Conservation momentum along
we know along
radius.
momentum conservation, I think we can apply. What was its initial velocity? V naught.
Initially, V naught, sir.
V
M
naught, sir.
into V naught
Is equals to M plus M.
M plus M
Plus M
into
V.
Sir, that is V naught along that direction only, I think, sir.
in which direction?
No, sir. V not
Along
V naught
radius.
is-
correct.
V naught is along this direction.
Yes, sir.
Yes, sir.
Along horizontal, it is not there. So I have to write along horizontal conservation momentum. I cannot apply total M V naught is equal to this. Momentum
yes,
is
sir.
conserved only along x-axis. Only
Along
along.
X, yes, sir.
This is one equation. From here we can get V. What else we want here?
MV naught cos theta by capital M plus small m, sir.
Then after
Then
getting
change
V,
in kinetic energy, we can get answer.
half M plus M into V square
Yes, sir. Minus half M V naught square.
minus half of M into
We'll get answer, sir. Yes.
getting from here change in kinetic energy.
Yes, sir.
So initial minus final. Change will be initial minus final. Initially is more and final is less. Final
Half
is less
m V
and
naught
initial is
square
more.
minus.
Yes. This is less and this is more. So initial minus final. Initial minus final. That is delta K. It is actually
Yes, sir.
minus of delta K, but
We can get it, sir. Sign only now, sir. Magnitude wise, we can do.
means from check once getting answer or not. Check it once.
We are getting, sir.
We will get,
Right.
sir. Right now.
Right then next up to 50,
Sir,
49, sir.
9, sir. They gave
49.
Once do the calculations.
Okay, let me check once. A rocket of mass 21,000 kg, 15,000 kg is the fuel. Rocket engine can exhaust the fuel at the rate of 190 kg per second. Exhaust velocity of 2,800 meter per second relative to the rocket. If the rocket is fired vertically upwards, then the thrust of the rocket is. Wait a second.
That is V into dm by dt on it.
Yes, sir.
Yes, it is V into dm by
By dt.
We
dt.
are
That is the
getting
thrust.
5,32,000, sir.
And 190 into 2800.
Yes, sir.
Let me check. Let me check it is right or not. Maybe you are doing some mistake. What is dm by dt? Dm by dt is 190.
Yes, sir.
190 into velocity. Velocity is relative velocity.
2800.
2800.
2800.
Then what is that coming out to be?
53200, sir.
532,000, sir.
00.
532,000.
It is direct only. What the question they are asking really?
Sir,
Yes, sir. But wait, sir. Answer they are giving 5.3, sir. It is 5.32 we are getting.
5.32 is right answer then.
they gave
Yes, sir.
It is
5.3.
straightforward.
They are getting.
I am really surprised. What kind of question they are asking? They want to check just can you do the product or what?
Yes, sir. Easy
It
question.
is very much straightforward only.
That's it, sir.
Okay. Right.
Yes,
No doubts.
Then fine. Now, can we start the next one then?
Yes, sir.
Next week's syllabus.
No doubts.
okay, sir.
Right. So wait a second. Where was that question? Which
Total 3
This
mistakes,
one.
I think.
in this today's paper?
Yes,
Yes, sir.
Yes, sir.
Okay. This class 1 I am giving here, and this is talk. So we start now. Today I want to definitely
Sir,
start.
once both the questions are apart.
Which question? Yes. Again, you are stuck here only.
Sir, there we wrote yesterday acceleration equal to d omega 1 by dt. No, sir, how we wrote that?
Mm-hmm.
One doubt.
Say what?
Yesterday we wrote that in this problem acceleration equal to d omega 1 by dt r cap. No?
Mm-hmm. Mm-hmm.
How we wrote that one? Alpha equal to
Why I wrote this thing?
how, sir?
Yes, sir.
That is direct formula only.
This is omega 1 is equal to omega 1 and omega 1 vector is equal to omega 1 magnitude into minus r cap. What is problem? It is direction only. Direction is along minus r cap.
Okay, sir. Okay.
Now only I explained. I think that our right hand thumb rule. If I cannot make my hand proper. This hand is not. I'm not able to make it properly. But this is how the omega is in this direction. In the direction of fingers. Thumb is pointing in this direction. So this is the direction of omega, which is pointing along minus r cap, radial inwards.
Yes, sir.
Yes, sir, inwards.
And after that, I just use the formula of taking the derivative. It is minus omega 1 into d by dt of r cap I did. And I told you that this we have done before in circular motion. D by dt of r cap comes out to be equal to just omega 2 into omega 2 cross r cap. It is omega 2 cross r cap into minus omega 1. Then I said that minus omega 1 again can be multiplied with r cap, and then it will again become complete minus omega 1 vector. If it becomes complete minus omega 1 vector, then it becomes omega 2 cross omega 1. Sorry, it will become minus omega 1 into r cap was omega 1. So it will become again omega 2 cross omega 1. That only.
Yes, sir,
that is
yes, sir.
understood.
Okay, sir.
Right. So now we can start the next topic. I am taking now instantaneous axis of rotation. Or wait, I think instantaneous axis of rotation, it can wait for some time. And before that, definitely I want to discuss one more important topic, that is torque. Torque is very important for this week, that I want to discuss first. So now I have two options here. One is I derive the torque first, or first one is that I give you the formula. Always see, I face these two difficulties always in all my classes whenever I am taking. One option I am having that I directly start telling the formula, and after that you start solving the problems. You can solve today itself. Sometimes I want to discuss the concept first properly, and after that I want to bring the torque formula, derive it, and then after that but if I start discussing the concept properly first, then sometimes times become so much more that in first class you are not able to solve many problems also, because I have not even given you way to solve the problem. So right now I will, I think, reverse it. I will tell you the torque. I will start doing its application. After that, I will come back again to the basic concept that how we ended up finding this torque, why this torque in fact works. Means I will tell you, okay, this is one formula and it works always, but why it works, for that we have to wait for some time. I will give you in detail. Okay, I will have to explain many things for that. So I will give you in detail. Right now, I'm just directly coming to torque formula, so that you can start applying it and you can start solving the problems quickly today itself. Okay, this choice I am making this time. So I think I cannot talk to this. Torque is defined as, and torque also I will define in two ways. One is torque about and about a point. First of all, I will define torque about a point. I will give you just definition. Means, because see, I'm now doing it in a opposite way. I'm not telling you why it works or why this torque concept is brought into picture first of all. Although that way mostly books also they don't tell anything, they just give the formula directly. Torque is equal to something called as R cross F. Very bad way to do, but unfortunately I am also following the same way today. Reason is so that you can start solving the problems today itself. R cross F, torque about a point, is given as R cross F, but I want to explain this thing in much more detail. If I have one force acting like this on a point here and or object P, about O I want to find out the torque about O point I want to find. Then I will say position vector of point P with respect to O into force which is acting at P point. That is the torque due to force about point P. So what I read it? I should call it as torque about point O. Torque about point O. Torque about point O due to force applied at point P. At point P or at body P, particle P. It could be P, could be particle, P could be just a point, P could be anything, whatever it is. At point P. So what is RP? O. You can see RPO is nothing but position vector of P with respect to O. What is O here? You can think O is origin. But I mean to say origin, which we are choosing as origin. Origin we are choosing as that point about which we want to find out the torque. So whenever we want to find out the torque, if I have chosen already origin as this, let us say somebody is asking you find out the torque about A point when the force is acting at B. Then for that moment, you assume that my origin is now A and I want to find out about, think like that. Then it will become position vector of B with respect to A cross F. That is torque. So F, this is the formula for the torque. Now here, unfortunately, this thing, if I want to really explain in detail, then I will, I think, have to make myself visible to you. Now, will I be able to do it or not? I will try once. Okay, once I want to maybe explain something by showing gestures also. So let us see if I can do that. Not only screen sharing will not be enough. I want to do something. So let me stop this right now, and I want to see whether it will be possible here or not. I'm sharing my video once. Can you see it on me or not? You tell me once.
So stop that background, sir. Then we can see proper.
Virtual background.
Okay, yes, that virtual background I have to stop this thing. Let me do it. Virtual background I will stop now. None. Right. You can see me now, right? You can see me.
Yes, sir.
Yes.
And I will try to make some hand gestures so that you can see what I want to explain here. Now, I don't know. I'm just trying it, whether it will be possible here or not. Let me see once. Okay, I will try. So let me take you to my door here, and in that door, I will explain you something here.
Video is clear, sir.
Clear, sir.
Video is clear, right? Then it is okay. I think it will work most probably. Then it's that is. Okay, so can you see this board here?
Not perfect. Door, sir.
Yes, sir.
Sorry, not board. Not board. The door, I should say. Sorry. Can you see the door?
Yes, sir.
At the top, we are able to see, sir.
Sir,
Door, you can see. This door, you can see, right?
Yes, sir. Yes.
You can see.
Top
it.
one,
So,
top.
The top half only we are able to see.
now,
It's yes.
Okay, sir.
okay.
Yes.
So this is the doorknob. This is the doorknob, and what I'm doing here now. Let us say I'm pulling this door. What is the meaning of torque? Torque is something. Whatever force does in translatory motion, same thing torque does in rotational motion. Means it tells us about the rotational impact of force. Rotational impact of force means how much rotation this force can produce. So even if I apply large force, sometimes it will be able to produce just less rotational.
Due to the point of impact, sir.
Yes, it depends where I am applying the force. It will depend on that. For example, see, this is a door now. This is a door here. and I want to open it from by applying force this side. If I'm applying force this side near the axis of the door, see, it is very difficult to move it. It is very difficult. You try it at your home also. Fine. It is becoming very, very difficult. On the other hand, why they keep that door knob here? Why we keep this handle here? Reason is this has to be large distance away from the axis.
Very far.
So that if I apply less force, even if I apply less force, I am able to move it easily. So it is becoming difficult when I am very close to the axis of the door and I am pushing it here, but it is not moving. See, it is not moving. And now it starts moving as I am going away and away. Now it starts moving. So it becomes difficult to move the door, rotate the door when I am very close to the axis. You understand that part?
Yes, sir.
Yes, sir.
You understand?
Yes, sir.
So means the rotational impact. The rotational impact does not only depend on the force, it also depends on the distance from the axis.
Position vector also.
Rotational impact also depends on the distance from the axis at which point I am applying the force. Okay. So then now what I am going to do here? I am trying to do one more thing now. I am trying to push this door. I am applying a lot of force, but I am applying around this plane. Please don't come here. I am taking class. Understand it? I am applying force in this way. So while I am applying force in this direction, means I am trying to put, I think you cannot see my hand. See, this way. I am trying to apply force in this direction, along the plane,
Yes,
along this plane of the door. Then can I rotate it by applying the force along the plane
No,
of the door?
sir.
No, sir. No, sir.
No,
I
sir.
cannot
No.
rotate it at all.
No, sir.
It means it is also important. It is also important at what distance I am applying. At the same time, it is also important at what
At
angle
what
I am applying.
angle? Yes,
Am I
sir.
What
applying
angle?
perpendicular
Easy,
to the
sir.
plane, or I am applying
Perpendicular
along this
is
plane?
easy.
Along this plane or
Perpendicular is easy, sir.
perpendicular is easy, right?
Perpendicular
Yes,
easy,
sir.
sir.
It means what is the rotational impact of the force? Rotational impact of the force is the perpendicular distance from the axis multiplied by f perpendicular. Force should be perpendicular to the plane containing that r and the axis. Plane containing r and the axis. Force should be perpendicular to that. And when the force becomes perpendicular to that, then it becomes easy. So the torque is not dependent on f parallel. F parallel means that force which is passing through that.
On the plane, sir.
If that lies on the plane, and that means if I extend that force, let us say I am making a force vector here, and if this force vector it passes through the axis on extending, if it passes through the axis on extending, then the torque due to that force above the axis
Zero.
will be
Zero only.
Zero,
No,
sir.
sir.
It will not be able to rotate. It will not be able to rotate it. Is it understood by you?
Yes, sir.
Yes, sir.
Sir, sir.
Is this part understood or not? Then
Understood.
right. Then it is enough. I can come back to now telling you here on this screen only. You will understand it now. Okay. So let
Okay,
me go
sir.
back to the screen. So right. Fine. So I am back here now. Can you see the screen now?
Yes, sir. We can see, sir.
Yes, sir.
Sir.
Yes, sir.
Okay.
So, now, let us say, so this was an example taken for the door. I can make a diagram of door here also, and I can tell you what I was trying to explain there. This is a door here, and this is the open door is slightly opened here, and this is the axis of the door. Axis. Here, if I am applying force in this way, will it be able to move it or not? It is
No,
parallel
sir.
to the door. It is passing through the axis.
No,
No,
sir.
sir. No, sir. No
If I
rotation
apply
is
force
taking place.
No,
this
sir.
way,
Yes,
along
sir.
the again in the plane only. All these are in the plane of the door.
No.
All these forces are in the plane of the door.
No,
I
sir.
No,
cannot
sir.
Plane we can't move.
even
Then
if
no,
I
sir.
apply force
We can't
parallel
move.
to the axis also. Even if I apply force parallel to the axis, then also I will not be able to rotate this
No
door
rotation.
above this.
No.
So if F is in plane containing, if F is in plane of which plane? The position vector and axis. There are two vectors, no? Axis and the position vector. Axis is,
Yes, sir.
let us say this is along A cap. If it is in the plane of R and axis, then somebody is making noise. Please don't do that.
Okay, sir.
If F is in the plane of axis and R vector, then torque due to F, torque due to F about axis will be equal to 0. It will be equal to 0. Understood?
Yes, sir.
And
Yes, sir.
same thing we are getting for torque about a point also. We can say when this torque will be 0. This torque will be 0. It will be 0. We can say, now let me write when it will be 0. You already know about the vector product. When vector product becomes 0, it is 0 if RPO and F are parallel or anti-parallel. Means 0 degree angle or 180 degree angle.
180.
Means then torque about
Torque
O
is
point,
0.
but it is still somewhat different. I'm here discussing about torque about axis, and here in this case I'm discussing torque about a point. I will come to torque about axis also, but right now I'm discussing torque about a point. So torque about a point, that will be equal to 0 if RPO and F are parallel or anti-parallel. Angle between them is 0 degree or 180 degree. Or another thing is possible. If RPO itself is equal to 0, then also it is possible. Means the force is directly acting at the point of application of force, and I'm also finding out the torque about that point only.
And also it is 0.
And also because then the RPO will become 0. Then
There is
RPO
no
0,
position
then
vector.
also, okay, then RPO will be 0 in that case. Means if I directly apply force at the origin, and I ask also to find torque about the origin, apply force at the origin and ask torque to find about the origin, then obviously that torque will become
There is
0.
no rotation, sir.
There is no rotational impact.
Impossible to rotate.
Now, based on this idea we have kept in mind. So, and one more thing, because it is a torque about O, I can write it as R cross F. So I can write it as RPO cross F, right? That will become RPO into F perpendicular. What does it mean now? Once I have two vectors, vector RPO and vector F, and I want to take the dot product of the cross product of these two, then I think you know already that cross product can be written like this. I can write it as RPO sine theta into F, or I can write
RP1 to F sin theta.
yes, I can write RPO into F sine theta. So if I say F sine theta, then F sine theta component is which component? F sine theta is perpendicular to RPO. So therefore I can write this thing as RPO into F perpendicular. Similarly, I can write RPO perpendicular into F. Both are equivalent. These are giving. Therefore, I was saying that it depends on perpendicular distance or perpendicular force. Force is perpendicular to RPO, then the torque is acting. But if force is just parallel to RPO, then torque acting becomes 0. So it is proportional to the perpendicular component of the force. We can say that, right?
Always angle between the vectors.
I gave you example also showing it clearly that how it happens, but now it is clear in the formula also same thing is happening, right? Or not? Okay.
Yes, sir.
So now other ways to, if this is if angles are given. When angles are not given, when they are directly giving us that RPO is given, let us say xi cap plus yj cap. Coordinates of P point are given there. This P point was here. Its coordinates are given x comma y. Then I can write now, and force was given as some vector maybe fi cap maybe. Then also I can say what it will become RPO cross F. Then I will use the formula for cross product, and I will write directly as I think I cross I will become 0.
0, sir. I cross y only will be.
Cap cross Fi cap. Then it is just y into F and j cross I. J cross I means
minus k cap.
Now observe, what does it mean minus k cap? What is this direction?
Direction, sir.
Direction
This is the direction. Minus k cap means into the plane.
Inwards.
That is
inwards.
Cross. That is this direction. This is the direction of the torque into the plane. So means, what do you mean by into the plane? Into the plane, you imagine that if I have a this particle here, this point here, what do you mean by into the plane? Into the plane means that clockwise also we can call into the plane as clockwise.
Yes, sir.
Clockwise. Sir.
Clockwise.
Yes, sir.
And it means it tries to produce clockwise rotation. What does it mean? It tries to produce clockwise Rotation. And I think everybody knows it, that if I have a, let us say this is a rod here connecting from O to P, and at P point I am applying force on the rod, then how the rod will be turning about O? It will be turning clockwise or not? Will it be turning clockwise or not? Say.
Yes, sir, clockwise.
I have a rod, and this force is applied on it, then it will be trying to turn clockwise rotation, it will give us. So means what we got from the formula, we are able to justify that it is correct only. It is producing clockwise rotation. Another thing now, somebody, before that I was saying that it may not be a rod also. It may be just a point which is not even connected to O. It will be just a independent point here P, and on which I may be applying force F. Can we still say that torque acting about O is equal to this thing only, which I am saying here? Yes, we can still say, because although P will be now moving in a straight line, but even then I can say the angle turned will be clockwise angle for the line joining O and P. If I take O and P is coming from P to P dash location, as it is being the force is being applied, but again the angle turned by angle turned is again clockwise or not? Angle turned is again clockwise. Means if an observer is observing from this place and he is looking at this, then he has to turn his head towards clockwise direction in order to keep looking towards, in order to keep looking at P point. Okay, so means we are able to understand that way. So torque concept is valid even in those cases where the body is not even rotating, but it is just translating,
moving.
Even if it is just translating, then also I can say what will be the torque about a given point in the space. We can still find out the torque about that point. So I hope you understand this part also. Is it understood or not?
Sir.
Understood.
Right. Next from here, although I told you that this is how we write in vector form, but let me tell you my experience says that no need to always use vectors. We can directly just do magnitude wise only, magnitude wise analysis. How to do by magnitude wise analysis? Let us take one example here. Let us say we have a system something like this, which is able to rotate about this hinge. It is a hinge here about the, or hinge or pivot about this, it is able to rotate. And I am applying forces which are maybe this kind of force acting here at an angle theta, and there is another force maybe this side F2, and it is F1, this is theta 1, this one was maybe theta 2, and there is one force here which is perpendicular to it, which is already F3, and there is one force here which is along the same direction, which is, let us say, F4. So question is, what is the torque acting upon, and its weight is acting here, mg.
Sir, hinge means,
what is the torque due to all the forces? Find resultant torque due to all forces about hinge. About which point we want to find? About hinge. So I should take hinge as a origin. That is a hinge is origin. Next thing, what we do next thing? Next thing is, this is line of force.
We can take point A and B.
Force. I will take a perpendicular on the line of force. I will take a perpendicular on the line of force, and I will say force into, let us say this length is given maybe, what should I give it? L by 2 length, half length.
Yes, sir. Angle theta
1. Can I find R perpendicular here?
Yes, sir. Fine.
We can find.
Sin theta 1 is equal to R2 top.
Listen. I don't recommend that. I will give you a reason why. Always we have two formulas. R perpendicular into F, 1. Second formula, F perpendicular into R. Which formula we should use? Whichever is easier to apply, that we should use. Here it is so easier to apply F perpendicular to R.
Yes, sir. F
perpendicular to R. Yes, sir.
F perpendicular is so easy. What is F1
F1 sin theta.
F1 sin theta 1 L by 2, sir.
I can say
F1 sin theta L by 2. Sin theta.
F2 sin theta 2.
Means
sin theta 1 into L by 2.
In fact, if I'm looking at this diagram, if I'm looking at this diagram, for me this diagram appears like this, which I will be showing you now. I will not worry about F4. I will quickly remove F4 because F4 is
it is along the axis, sir.
Along the axis there is no rotation, 0. Torque is 0, sir.
remember one thing, how to tell quickly. I think I should explain again once more how to tell quickly that whether the torque acting is 0 or not. I'm giving you one force here. This is force F. And to tell me whether the torque is clockwise or anti-clockwise or 0. F force is acting. One point is A, one point is B, one point is C, one point is D, one point is E, one point is F. Tell me about which point torque is 0.
B and E, sir.
B and C, sir.
And
B and D, sir.
B and E, sir. B and E.
B and D.
0.
B and D.
Talk about E 0. So
Also 0.
how
It
did
is along the axis, sir.
Along the axis.
Along the axis. Along the axis.
No, don't. You are still. Just extend the force and say if the line of force passes through the points, by extending the line of force passes through the points, then directly the torque about those points will be 0.
Okay,
Remember
sir.
this thing. If
Okay,
line
sir.
of force, if line of force
Then
passes, if line of force passes through certain points,
that point about is
Certain
0.
points, then torque
About that point.
about such points will definitely be 0. That will definitely be 0. Example here, torque B is 0 and tau is 0 because of this reason only. But this is important point to be remembered. Line of force. What is line of force? When the force is extended, I use this word several times. Line of velocity, line of normal. I mean, force is just one vector only. But if I extend this and make a line of it, then that is line of force. And when that line of force passes through certain points, then the torque about such points will always be 0.
0, sir.
So just remember this thing only. So there will never be any confusion. You will extend that line and you can quickly see whether it passes the points or not. Now, another question I asked, about which points the torque is clockwise, about which points the torque is anti-clockwise. That also you have to tell. How to tell that to know? About which points the torque is clockwise, about which points the torque is anti-clockwise.
E and F.
About A,
Cross product.
it is anti-clockwise, sir.
Direction of cross product.
Anti-clockwise at A, sir. C at clockwise.
He is saying by direction of cross product, but I'm telling you, don't confuse yourself by the cross product. Because
Direction of force also you can say.
think physically. When I'm saying about D, assume this is the line of force. Assume there is a hinge at D. Assume there is a hinge at D,
And force
there's a rod.
component perpendicular again.
There's a rod here, and on that rod I am applying the force. Then how this rod will move about the hinge?
Anti-clockwise, sir.
Anti-clockwise.
Anti-clockwise, sir.
Similarly, when I want to discuss about A, then take the
A
hinge at
also
A.
anti-clockwise.
Then now it is moving
Clockwise.
away.
Anti-clock.
Then
Anti-clock.
hinge at
Clockwise.
How is it?
Clockwise.
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 D also
A
clockwise.
also clockwise.
So D and A talk about D
Anti-clockwise.
anti-clockwise and talk about F and talk about C
C. Clockwise.
wise. These are clockwise. Anti-clockwise
The
and
torque
clockwise.
about D and torque about A, no, sir.
D
Anti-clockwise.
and A, and this is F and C only. Yes. So talk about D and talk about A anti-clockwise and talk about F and talk about C clockwise. Is it clear now? Can you always be sure about the direction? Just imagine A, take the line of force first of all. What we should do first? First take the line of force.
Line
After
of
taking the line
force.
take hinge, imaginary hinge, even if it is not there, take imaginary hinge at that point. About which point we should take imaginary hinge? About the points about which I want to find out the torques. Once we take that imaginary hinge, then after that see how this body will take some rod which is perpendicularly lying on the line of force, and that rod which is perpendicularly up to the line of force, extending up to the line of force, how that rod is turning, we will see that. If it is turning anti-clockwise, then obviously anti-clockwise torque. I hope it is clear now.
Yes, sir.
Then
Yes,
right.
sir.
Then same thing we will do here now. We will not worry about that cross product. I'm not saying that you should not use that. Sometimes we have to use cross product only because it may be given in vector form. But whenever it is not given in vector form, they are giving in terms of angles. Then I don't tell you to first resolve into vectors and then start doing it. No need to do that. No need to resolve into vectors. Directly we can do. Here also, what I will do now, I will think that there is no F1 here, but I will take only F1 perpendicular. Similarly, I will think there is no F2 here, but I will think only as if there is just
Put this in anti-clockwise
F2
torque.
perpendicular, sir.
F2 perpendicular is F2
Sin theta 2.
sin theta,
Theta 2
Sin
and
theta
F1
2.
sin theta 1, sir.
F1
sin theta
sin
1.
theta 1.
1.
What about MG? MG plays no role again because it is
No,
passing
sir.
through the
Point of contact, hinge.
Hinge, sir. Passing through hinge.
Passing through hinge.
Torsion.
so it does not play any role. Then we
Yes,
are left
sir.
with these two little forces only, and it is so easy to find out the torque and see is it clockwise or anti-clockwise due to this.
Clockwise, sir.
Clockwise.
And what about this here?
That is also anti-clockwise only.
Anti-clockwise. 2 are
Both are
anti-clockwise.
anti-clockwise. So if forces
Yeah,
are acting in opposite direction, does not mean
Again.
does not. If, you are disturbing me. If the forces are acting in opposite direction, does not mean that the torque will be in anti-clockwise direction. One may be anti-clockwise, other may be if the forces are acting in opposite direction, does not mean that torques will be in opposite direction. See, the forces are in opposite direction, but the torques are still in same direction because R vector is also opposite. Here R is also changing sign. R is here. If I have to take, let us say it is A and it is B, and this is the point about which I want to find out. This is O, let us say. Then it is RBO and this is RAO. We can see that RAO and RBO are in opposite direction, right?
Yes, sir.
And forces are also in opposite direction. And we know that the torque becomes on the product. Torque is dependent on the product. So therefore the product remains same, and the torque remains independent of R and F. Torque remains like that only. Okay. The product remains.
Forgot about F3
What is
also.
the distance of F3, sir?
F3 also there, sir.
Three also
Sorry.
have
Yes, sir.
downward.
What kind of torque it is producing now?
Anti-clockwise, sir.
Yes,
Clockwise.
clockwise. Now use some convention. What convention? Take one torque as positive and take other as negative. Which one you want to take positive? Your choice. For example, you can take
Anti-clockwise.
F2 anti-clockwise positive, sir. More.
anti-clockwise
Generally.
positive. Generally anti-clockwise positive. So let us take that only. Anti-clockwise. Let us follow general convention. Anti-clockwise positive. If I do that way, then I will be getting, first I will write anti-clockwise torques. What are the anti-clockwise torques here? Those are
F2 sin theta 2.
F2 sin theta into perpendicular distance from the axis. What is the
RBO.
perpendicular? L by 2 already.
L by 2, sir.
L by 2 plus F1 sin theta into L by 2 again
Yes, sir.
minus
F3 distance.
this
L by 4.
let us say L by 4.
Yes, sir.
L by 4 then minus F3 into L by 4. That is the net torque about point. Which point? About point? About point. Oh,
Due to MC dot 0 only, no, sir.
MG has 0 only. It is passing through the O point. Therefore, I am not taking MG. Where I have taken MG here?
Yes, sir.
Due to MG, it is 0 because MG is passing through O point. If
Hinge.
MG is not passing through O point, then due to MG also I have to take torque. Okay.
Yes, sir.
Is it understood now how to take the torques? Can you take the torques now easily?
Yes, sir, we can.
Right. So this part is clear. Another part now, from here, I will discuss one more thing now. Torque about O point, torque about any point you can find now. Even if it is not torque about origin, torque about another point, then you can take that as origin for the timing and you can start finding about that point, no problem in that. Torque about axis, this is still to be clarified. Torque about an axis. What does it mean? And why is it different from torque about a point? Torque about a point means the net torque. But torque about that point. But torque about axis means, see here, let me go back to our torque which we calculated. What was our torque which we found here? What is the torque which we found? YF minus K cap.
Yes, sir.
About which axis the torque is? This. What is the direction of this torque? This direction is minus K cap. What does it mean? It means torque is acting
Clockwise.
about Z axis. It means first of all that torque is acting about Z axis because it is along minus K cap.
Negative Z axis.
What is its other component like No, you say just z axis. Now about z axis clockwise or anti-clockwise we can say, but no need to. Okay, means it is minus k also z plus k also z, right? It is acting about z axis. It is also fine if you say it is about negative z axis, no problem. That is also same thing. But is it acting about y axis here? No, because the j component is 0. There is no j
Zero.
component.
I also 0.
Then what is the torque about? What is the torque about y axis, and what is the torque about x axis?
Both of 0 only.
0. So this
Yes,
is
sir.
y axis and this is x axis, and this was the force. And I can say this thing in another way also. I can say because the line of force by extending passes through y axis. Because the line of force by extending passes through y axis, therefore torque about y axis becomes 0.
0.
We can say that. So now I'm telling you one thing. When the torque about axis, what is it meaning first of all? So if I have a axis like this here, this is the point about which I found the torque. That is the net torque tau. And axis is this side. This is axis. That is axis is pointing in a cap direction. And I want to find torque about this axis. Then I have simple formula. Torque about axis
Perpendicular
a cap.
along that axis.
A cap. Torque
Yes,
out
sir.
a capital.
Dot
So net
product
torque
we
once
need
we have found. Net torque once we have found, then we can take torque about any other axis by taking just dot product with what? With
Axis.
Direction.
vector, unit vector lying along the axis. It is a cap is unit vector lying, or what, why should they say lying? Unit vector along axis. Unit vector along axis direction. That is this a cap. And tau is the net.
This one was 0 now, sir. That is due to perpendicular now, sir.
Net torque about O. Okay, that it is. So we know now torque about this will become then tau magnitude into unit vector has 1 unit magnitude, so tau cos theta. What it will become? Tau cos theta. It will become tau cos theta. Let us go back to our previous example where this was the force and the force was here acting like this, and this was some maybe value given as x comma y was given, and I want to find out what is the torque acting on it, and about origin first of all. What is the torque about origin? As you already know, we found it x I cap plus y j cap cross f I cap. F is along I cap here, so it will become
Minus Fi K capsule.
I cap. Then what I should say? I should say torque about O point. Net torque about O point was coming out to be minus f yf into k cap.
Yeah.
This was our answer, right? But now we will say this thing also, that what is the torque about 0 into j cap? What is the torque about x axis? 0 into I cap. Means the force can have, the torque can have 3 components. It is a vector, it has 3 components. But the other components are in this case just 0 only. The other components are 0. Or if torque about y axis is 0 and torque about x axis is 0 and torque about z axis is equal to minus y into f, it gives us this idea that the torque about axis is not same thing as the torque about a point. So if I'm finding torque about a point O and I want to find out torque about axis passing through same point O, first of all, this axis should be passing through some point O only. If I'm taking another axis, which is this axis, and I want to find torque about this axis, then I cannot just take the component of the torque which I found about O along this axis. That would be a stupid thing to do.
Point
Because
should be
point-
on axis.
Point should be, yes,
On the
the
axis.
point should be on the axis first of all. If I take this axis and this axis is some other axis A cap, along A cap
You
direction,
can find, sir.
then again I can find the torque about that axis also. What it will come out to be in fact 0 only. Why? Because this axis also lies in xy plane. It is also in which plane? In xy plane. And our vector
So our torque was in z axis.
torque was in z axis. So any vector which is along z axis, its component in xy plane will come out to be 0. So any axis which lies along xy plane and passes through this O point, about all those axes, the torque will come out to be just 0. But if I take another axis now, let us go to a little bit 3 dimension. This is z axis, x axis, y axis. This was how it was moving in fi cap direction, and this was that point which was having coordinates x, y here, right? And we wanted to find out torque about origin. We found already. But now I am taking another axis here, this red axis, and this axis has direction which is making some angle theta with z axis and 90 minus theta with y axis. Means it is lying in which plane? It is lying in yz plane.
YZ plane.
If it is lying in yz plane, but our torque was in which direction? Torque was along
Z
Z
plane.
axis, sir.
z
Z
axis.
axis.
Oh, unfortunately it was along minus z-axis. It was means diagram will become more complicated for me to draw. Okay, it's backwards. That torque was along backward direction. But anyway,
In angle, we need to consider 90 plus 90 minus.
Then I think, but anyway, these are opposite only. So this is theta. This angle will also be theta with this.
Theta only, sir. Yes, sir.
So then it is simple only. I can take component along that axis and I can get the answer quickly. I can say what is the torque about that axis, right? We can find it out. So we are able to determine. So don't worry about this thing that it is becoming too complicated. See, main idea is that if I have to take the torque about axis, then it follows just from the, it is nothing. We already know that if I have a component vector A and I want to take its component along B, we have done in vector class directly in the beginning itself, that it will be just A vector dot B cap will be component of A along B. So there is nothing new to this. This we have been doing from so long, but when we start discussing in torque, then you will feel as if it is something related to torque. No, it is related to vectors. It has nothing to, any vector, if I have to take its component along any other direction, then I will do in the same way only. But yes, something related to torque is this thing, that I cannot mindlessly just think that, okay, we will do always like that only. I have to think one more thing, that it should make physical sense. Means axis should be passing through that point. If axis is not passing through that point and you start taking the dot product directly along that A cap vector, then mathematically it may not be any problem for us. I can take component, but physically it will be a problem and that will not be making any sense. So we should take the component only if the point itself lies on the axis itself, about which we are finding out the torque in the first place. Is it clear?
Yes, sir.
Right, very good. Then you have understood this. Now I can move on to the torque about. Okay, one more thing. How torque about axis will be 0? How to tell quickly without having to go now? If somebody has to always do the cross product and then only you can find out what is the torque about axis, and then it will be very lengthy. No, I don't want you to go into such lengthy complications. What we should do instead, we should just take XY plane, and in that, let us say F is the force, and in that, I can say why it is coming out to be 0. I will say this quick reason for you. Torque about n axis is equal to tau dot a cap, and torque about axis is tau dot a cap, which is also equal to, what should I call it? I should call it, I should represent it maybe tau a. Tau a means component of torque along A axis, along A axis. For example, if it is along X axis, then I will say tau X. If it is along Y axis, I will say tau Y. If it is along A axis, then I will say tau A. Is it okay?
Okay, sir.
Right. So it is tau dot A cap. Now, what it will become? It will be R cross F. R is this here, cross F dot A cap, and that is called as scalar triple product. You may not be remembering it now because I did it long time back in.
I remembered, sir.
You remembered very nice. If you remember it. Do you know what is the significance of this? What is the significance of this scalar triple product? Its significance is that it gives us the volume of.
Yes, the volume of cuboid.
Yes, very nice. You understand. You know, volume of parallel piped. I should say volume of parallel piped formed by volume of parallel piped formed by vectors A, B, and C
yes,
is given by A cross B dot C or
A bar dot B cross C, or we can write, sir.
B cross
or C cross C bar.
We can write in 3 ways. Or how can we write now? Next, A B means okay, means as long as the order remains same. Order should be same. A B C.
Then it is 2 only, sir.
C B A cyclic order.
B A C.
BCA, no, not BAC. BAC means order is reversed. I cannot take BAC. ABC, BCA, or CAB. CAB, cyclic order. This thing, I did something wrong here.
Sir, not CBA, sir.
D, sir. CAB, sir, it was.
BCA.
Yes, sir. Now it's correct, sir.
As long as the cyclic order remains same, then it is same thing only. And it does not make a difference whether I take B cross C dot A or I take B dot C cross A. It does not make a difference if I take A cross B dot C,
Right.
A cross B first, or A dot first and
First A dot and next cross.
All these are same. As long as these are in same cyclic order, these are all same. So means, okay, mainly come back to that point of volume of the parallelepiped. And we know volume of the parallelepiped is 0 if the three vectors are coplanar. If A, B, and C are coplanar, then volume will become 0. They cannot form any volume if all are lying in the same plane. Then how can they form a parallelepiped? Volume will become 0 or not?
Yes, sir.
Right or not? Okay, volume will become 0. If you are not understanding in this way, you understand in another way. A cross B is perpendicular to plane of A and B. But now when we are taking perpendicular vector and taking the dot product with something which is lying on the plane, then it will come out to be 0. That way also we can understand.
0.
Okay, so we know that volume will be 0 when these are lying in same plane. Now here you understand F vector, R vector, and the axis Y were in same plane or not? Are these three in same plane or not?
Yes, sir.
Axis, sorry.
Same plane, sir.
Axis, F and R in same plane. Then about that axis, about Y axis, I can quickly say that torque about Y axis should be 0 because these three vectors are lying in the same plane. Same way I can say X axis, R axis, and sorry, X and R and F. These are again in same plane. If these are in same plane, then again I can say that torque about X will also be 0 by the same logic. Is it understood or not?
Yes, sir.
Say
Understood,
something.
sir.
Then you know
Same
now
plane.
you have really understood in a very nice way now that what is the torque about a point and what is the torque about axis and when the torque about axis will be 0. And I told you also one more thing, that don't go into finding out the cross product and resolving into vectors. Always use what method? Use the method of, if I want to find out the torque about a point, if I want to find out the torque due to force F, then always I imagine, I can do this thing also. Imagine a clock. Imagine a clock. And imagine this is a hand of clock. If this is a hand of clock and this force is being applied on that clock, then how this force will turn this clock? Imagine like that only, because I want to find torque about this point.
Clockwise.
Imagine this. It is
Clockwise.
hand of
Clockwise.
clock. It will turn it clockwise direction. And
Yes,
what
sir.
will be the,
Yes, sir,
which will be
clockwise.
responsible for turning? F
Perpendicular component. Perpendicular.
Perpendicular component.
If length of hand is L, then what will be the answer for torque?
FL, sir.
Perpendicular into L. Direction is
Perpendicular into
clockwise.
yes.
Direction is clockwise. Always we can do like that. Always we can do like that. Imagine a imaginary clock there. Imagine some hand there on the force. And I told you before another way also. What I told that take the line of force first and then drop a perpendicular on that line of force. This also we can do. Take a line of force and drop a perpendicular on that, and then it will be R perpendicular. That is same thing.
And also same only, sir.
Either then also same thing. Here I'm not taking the line of force here. Here I'm taking the component of force along the perpendicular to the hand. I can do that. Or I can take the line of force and I can, after that I can draw the hand. Before that I will not draw the hand on the clock. First I will take the line of force. After that I will draw hand perpendicular to the line of force. Both ways we will be getting same result. And always I will recommend you to use this method only. Is it okay now?
Okay.
Yes, sir. Okay, sir.
And then let us start solving some problems. So this week mainly we will be what is the formula for torque?
Can you say this week's syllabus, sir?
If net torque acting on a body is 0. It is only torque 0 cases in this week's syllabus. If net torque acting on a body is 0, then body will be in
Rotational equilibrium.
Then body will be in rotational equilibrium. Means it will not rotate. It will rotate with constant angular velocity. Rotational.
Mainly torques, sir, this week.
What?
Mainly based on torques. This
What
week's syllabus, sir.
Just torque. Mainly torque and listen. Please let me finish. Mainly torque and that too torque equal to 0. Not the cases of torque is equal to I into alpha. Not those cases. Only when torque is just 0 only. When the bodies are not moving. When the bodies are at rest. Only those cases. Okay.
But we are having unit test on this.
But you are having?
Yes, sir. Unit test. Collisions
Unit test.
also will be involved.
Full collision,
That
sir.
That is different thing. Unit test is there, but otherwise this is only there in syllabus for the torque as far as.
I'm asking about this one.
Okay. Now you tell me, find out the T1 value and find out the T2 value. Can you find out the T1, T2 values? So I told you, up to this what I have told you. I have told you that how to take torques. I have told you that. But about which point to take torque, that I have not told you, when especially when they are not saying that about which point you should take. For example, if I ask you, find good afternoon. Sir, I am taking class now. Can I talk to you after 1 o'clock? Okay, sir. So about what I was right. For example, somebody is asking you to find out the tensions T1, T2. Find the tensions T1 and T2. And you know which equation are you are having? You are having equation sigma Fy is equal to 0. But unfortunately, that is one equation, and there are how many unknowns?
2 unknown.
Means I need one more equation. I need
equations, sir.
Net torque is equal to 0. Equilibrium condition is this is rotational equilibrium. This is translational equilibrium. How many equations do we get from translational equilibrium? We get 3 equations along Fy, along Fx, along Fz. 3 equations from translational equilibrium. And how many equations we get from the rotational equilibrium? 3 equations from the rotational equilibrium. But in most of the cases, when the motion is confined to one plane, then this will be just one equation, and this will also be just one equation only. Because I will not worry about what is happening in the other direction. In other direction, if I want to apply, what is the net force? Let us say I want to apply this. Sigma Fx equal to 0.
0 only, sir. That is no force.
Equal to 0. I will say no force along X. No force. Similarly, sigma Fz is equal to 0. 0 equal to 0. Means it does not give us anything. So therefore, mainly we are confined to, although there are 6 equations, but out of those 6 equations, we are just confined to 2 equations only. Rotational equilibrium and translational equilibrium. Now, in these 2 equations also, you are not comfortable with torque equation now for the timing, but actually torque equation is much easier than the force equation. I will tell you afterwards. I will tell you why it is much easier and why it is more advantageous. You will soon understand it. It's much easier than the. But point is, about which point should we take torque? The question. About which point we should take the torque? We should take torque. This is common thing which they say in the books, but it is not right. It is not right. We should take torque about any point when it.
Yes, sir. Any point we can take, sir.
About any point we can take. It is 0 about any point.
Yes, sir.
About any point, and then also it will be safe. Okay. So understand this thing here, that which points are convenient. No, okay, we can take torque about any point. About all the points, it is 0.
Center of mass only we can take.
About all points. How do I know about all points? Because if I take one point here, A, this may not be on the body also. About this point, if I look at the body, is the body appear to be rotating? Is it appearing to be rotating, or is it remaining stationary?
Stationary.
Remaining stationary only, sir.
Then, then about A also torque should be 0. If I take the point about B also same thing. Means from wherever we are looking at it, it is stationary in all those points, with respect to all those points.
Sigma tau should be 0.
That means we can apply torque about all those points. But now, which are, and another question. So about all points we can take? About which point? About all points. Answer is about all points, because the body is at rest. Because when body is at rest, about all points, when body is at rest. When body is at rest. Then about all the points. And what about the cases when, no, which is convenient? Sorry, I was discussing another thing. Which is convenient point? Which is convenient point? And today I cannot help, but I have to take class in the evening. You like it or not, but it is really, because I really have to take more things before I start doing some problems. So today I have to take class today in the evening also, okay? And in the class, if you are not understanding anything, please let me know there on, okay? If it is becoming tough for you, then let me know. Which is convenient point? So convenient point, that is another question. That point is convenient, which will be able to make most torques 0. Which will be able to make most torques 0. Which point is able to make torque 0? If I take torque about here A point, and if I take torque about B point, then due to T1, what is the torque about A? Due to T1, T1 is passing.
T1 into, yes, sir. 0.
And what is torque due to T2 about B point?
T2 into 4x, sir.
T2 into 4x.
T2 into 4x.
Into 4x.
No, first listen only. about which point we should take the torque? About that point, about which that I don't have to take one tension T1. Why? Because T1 due to T1 torque is coming out to be 0. About B, similarly, B is convenient because due to T2 the torque is coming out to be 0. Then I have how many unknowns left now in one equation when I write about A? Let us write about A. Torque about A is equal to 0. Then I do I need to write for T1? You write for formality, but it is 0 only. T1 into 0 plus mg into 3x. Direction. If I take A, this is a hinge now. I am assuming A to
That
be
is
hinge.
clockwise.
This is the clock.
Minus
This time
mg into
clockwise.
Minus.
Put a clockwise sign here, and or you can write minus because clockwise we take as minus.
Yes, sir.
Write minus sign here. Minus. What about due to T2? Plus
Anti-clockwise, sir.
Anti-clockwise.
is equal to 0. What is T2 then? T2 is just
3mg by 4, sir.
Notice one equation and answer quickly. So is it not really convenient to write about A? After that,
Yes, sir.
write about B
Convenient.
to get answer fast. Or now you can use this equation. Also T1, T2 plus T2 is mg. You can use this equation. Then you can get T1.
3mg by 4x. I think.
T1 plus T2 is equal to mg. So we are getting T1 is equal to mg minus T2. That is
3mg.
mg. Yes. Yes. Say something.
Sir, I think 3mg by 4x.
No.
XX get cancelled, sir.
Oh, okay.
X6 cancel, sir.
Okay, sir.
No, dimensionally it will become incorrect. If I take x here, dimensionally force must be. Okay. So this is right. Mg minus T2 is equal to mg by 4. So see, is it becoming easy that way or not?
Easy, sir.
Easy, sir.
So which is convenient point? Again, question. Which is convenient point? Do you remember this thing or not? That
Sir.
point is convenient, which can make the torques 0 due to some
0.
tensions. Due to some tensions, the torque will become 0, or due to some other force.
Then we can get answer quickly, sir.
And we can get answer quickly. Now I will check you. I will see whether. Okay, one more thing here. Equilibrium under the action of 3 forces. If there are 3 forces acting together on a body, then how the 3 coplanar but not parallel forces. Coplanar forces are there but not parallel. Then remember one thing. If I know 2 forces are acting in certain direction, and I know about those, then I can find out the point through which those 2 forces pass. Can I find that point or not?
Yes, sir.
Yes, sir, we can find, sir.
Yes, sir.
By joining.
By joining the line of forces, I can find. Then the third force, which I have to exert to make this body in equilibrium, I definitely have to exert in such a way so that the line of force of that also passes through this point. Otherwise, but I'm not saying in this direction. I'm not saying in this direction. Direction could be any other direction also. Direction could be this side also.
What
But the
about
line of
planes,
force must.
sir?
What? All are in same place. Coplanar.
Okay, sir.
Same place. This force must pass through this point. Why? Somebody, let us say I want to make the body in equilibrium. Can I make this body in equilibrium like this here? I can take the force this way?
No, sir.
Not possible. Reason? Why it is not possible? Let us say I want to take the torque about A point. It may happen that torque about A due to F1 and torque about A due to F2 and torque about A due to F3 cancel each other. Is it possible or not? It is possible, I think, because they may cancel each other and the net torque may come out to be 0.
Yes, sir.
But idea is this. As I said, if a body is at rest, then it should be in equilibrium not only about one point. It should be in equilibrium in
all points, sir.
All points, sir.
All points.
I know one thing, that about P, it cannot be in equilibrium. How do I know?
Yes, sir.
About
Yes, sir.
P, what is the torque due to F1?
0, sir. F2 0, sir.
0.
But
Zero.
F3 is
F2
having some
also.
torque.
F3 having some torque.
Is exerting. So torque due to F3 is not becoming
Yes,
0,
sir.
but torque due to F2 0. Means about P, I can quickly say that torque due to F3 is not 0. And if it is not 0 about P, then this
Not
body
at
is
rest.
rotating. And if it's not
Not in
rotating,
equilibrium.
then it is not in equilibrium about other points also. If it is not equilibrium about P point, then it is not in equilibrium about other points also. And when that happens, see, if a body is in equilibrium about one point, rotational equilibrium about one point, then it will be in rotational equilibrium about all other points in the space.
All points.
But if it is not in rotational equilibrium about point P, then it will not be in rotational equilibrium about point A, B, or any other point. Okay.
Yes.
Therefore, I can say that in order to make this body in equilibrium, I will have to make the third force also must be passed. All the 3 forces must be passing through the same
Passing to the
Same point, sir.
if there are just 3 forces only, if there are just 3 forces, and these are coplanar but not parallel.
Coplanar.
If these are parallel, then I can achieve in another way also. Go to the last example. Here also, how many forces are acting on this body? 3 forces.
3
3 forces.
But these
2
are able
times
to balance it or not?
tension or
Able to balance
Yes,
it.
sir.
balance, sir.
But
Yes, sir.
these are
Balance.
these are
Not
parallel.
passing through any point. Common
These
point.
are- But I was discussing here about coplanar but not parallel forces. So if there are three forces which are coplanar but not parallel, then those three forces must definitely pass through the same point. That is the idea here. Okay. Then three
Okay, sir.
forces must
After the same point.
pass through same point for body to be in equilibrium. For body to be in equilibrium, three forces must pass through the same point for body to be in equilibrium. If what happens? If F1, three forces must pass through the same point for the body to be in equilibrium. If F1, F2, and F3 are not parallel to each other. If they are not parallel, then they must be passing through the same point.
Passing through the same point itself indicates they are not parallel.
No. You are still not understanding.
No, sir. I understood the
they
concept.
must pass. No, but still, the way you said, no, if they are passing through the same point, then they must. What is the point here? I am saying that if this happens, then this will conclude this thing. Then they should pass through the same point. I am not going from this to this side. That if they are passing through the same point, then they are not parallel. You are going vice versa. I am saying this thing, that if this thing is given to us, and it is given that the body is in equilibrium, two things are given to us. What are given to us?
Okay, sir. First this one, next this. Okay, understood.
This is given, and this is given. Then we should conclude. This is the conclusion. This red color is the conclusion here.
Same point.
I was thinking first you written this one, later you are right.
No. But I wrote here if it is given.
Yes, sir. Yes, sir.
Okay. For body to be in equilibrium. Body is in equilibrium and these are not parallel to each other. Then they must pass to the same point. That's what I'm saying. Is it understood now?
Yes, sir.
Okay, right. Next, here,
Yes, sir.
one more thing I should add now. About four forces. I think I can tell about some four forces also. Okay, here already it is mentioned, written already by me. This minimum number of non-coplanar forces required to keep a body in equilibrium. If these are not coplanar also, and I want to make the body in equilibrium. Non-coplanar and also I think I should again mention not parallel. Not parallel also, not parallel or anti-parallel. Then how many forces do I need to make a body in equilibrium? I think not. This is enough. Not parallel, not required. Automatically, it will be not
Yes,
parallel.
sir. That one
These are non-coplanar.
non-coplanar.
No need. Then I need to see 1, 2, 3. These are not coplanar. Means that these are forming like a tetrahedron, let us say. Then there will be another force required to balance the three forces upwards. So these are the three along the edges of the tetrahedron. Then the fourth force will be trying to balance it. That has to be acting in such a way so that the vector sum of the resultant of F2, F3, F4 should balance. Vector sum of these three should balance F1. Then only this body will be in equilibrium. And all these should again pass to the same point. Otherwise, if they don't pass to the same point as before, then the torque will not be 0. Then the torque will not be 0. So how many forces do I need to make the torque to be 0? There should be at least 4 forces. Then only we can keep the body in rotational and translational equilibrium. Is it okay?
Okay, sir.
Okay.
Right. Very good. You understood this also. I am happy to see that. Now, these things here. These things, okay, wait a second. Some review. I have already discussed certain things before, and those things can be asked this week also. You remember that I used to ask you at that time in center of mass chapter itself, such things, but although at that time it was wrong thing to do, because I told you the reason for that I will explain later on. But I used to tell these things there also. What was that? That was something like this. This is a U-shaped wireframe, and I used to ask you that what angle this will make with this vertical imbalance.
Yes, sir. Yes, sir.
Yes, sir. You asked this, sir.
And
Yes,
I
sir.
asked one question here that I think that what will be the maximum overhang achievable, something like that I used to ask.
Sir, we should place at center of mass.
So now I used to tell that thing that center of mass should be lying vertically below the point of suspension, but there the reason was not clear. Why we should just lie vertically below the point of suspension? Now reason is clear. See, how many forces are acting on this total? hinge reaction, R force. In which direction hinge reaction is acting, I don't know, but it is passing through this point. When there are two forces, and one of these passes through P point, then the other force also must pass through same point, otherwise torque will become non-zero. So mg must pass through same point, then only torque will become zero. Is it right or not? Because one force is already passing through the same point. Then other force must pass through same point, then only torque will be zero. So for the rotational equilibrium, it is compulsory on us when there are just two forces involved, one mg and other r, then automatically the mg and r should pass through same point, then only the body will be in rotational equilibrium. And when that happens, then automatically mg should be lying somewhere in the same line. Now whether vertically below or above, that doesn't matter. It may be above or it may be vertically below. For example, in such cases, mg will be above the normal. It will be above it, above the point here, right? So it may be lying above or it may be lying below, but it should be passing to the same point. And
Same point.
So this is understood now. Is it clear now why we used to do that in that way?
Yes, sir. Understood.
Just by rotational equilibrium. Okay. Now this thing here, this body is in equilibrium because it is said it is just about to slide, but not sliding. If not sliding, then it is in equilibrium, rotational equilibrium. It is a spool. This thing we call a spool. And there is a tension T acting here on this, and some friction will be acting. I don't know in which direction, and there will be one mg acting onwards. mg sin theta, I should say, I think. Mg sin theta, and normal will be acting. So many forces are there. Normal is acting, and mg cos theta is acting. Mg cos theta, and friction in which direction? What do you think? Upwards or downwards?
Upwards, sir. Upwards.
Upwards. Its tendency is to move downwards.
Maybe upwards, but I'm not sure. Okay, I'm
No, sir, because mg sin theta and tension values, it depends.
I don't know, but when I don't know, then I will choose some direction. I at least want to say that don't worry if you don't know. If you don't know, don't worry. You can still assume any one direction, and I'm assuming right now upward direction. And because I said it is just about to slide, so I can write it as mu into n also. Just about to slide. So now the question goes like this: that what will be the tension? So how to find tension? I think we can say torque balance and force balance.
Yes, sir. T plus mu n is equal to mg sin theta.
If I write mu into n plus t
is equal to mg sin theta.
mg sin theta.
And torque along the center, sir.
I think this is enough to get the answer or not. I think we can get from here also.
Yes, sir.
From here itself we can get. This question I should not have asked in this way. I think I should have asked.
I think something should be variable, sir.
No. Wait. I will, because I have opportunity to ask. It is not given. Just about to slide condition is not given. Leave the condition. And I want to find the friction here and tension. Now there are two unknowns. So forget the condition. I gave it. I don't know why, what I was thinking at that time. But it is not. Maybe I wanted to find out the quotient of friction. I think so. That's why I gave it. So I know I understood why I was asking that thing. I was saying that thing because I wanted to find out quotient of friction here. That was not given to us. So okay, no problem. Then we can take this also. And mu is not given. Mu is unknown. So it is mu into n. So two things I have to find. So I need one more equation now. Which equation I need now? I need the equation for the torque. So about which point should we take the torque? Now one option is about center of mass. Another option is about the point A. One option is about the point of contact P. Which is most convenient of all these?
Point A is,
I told you
tension becomes
that
zero.
point is most convenient. That point is most convenient, about which most of the torque due to most of unknowns becomes zero.
Yes,
so I think, and we have to take less number of torques also. I think
Point
point
P,
is the
sir.
most convenient. Why?
Yes, sir.
I have to take no torque.
Friction is zero.
Due to mg cos theta, no need to take. Due to normal, no need to take. Three torques vanishing. Three torques are vanishing about P point. Quickly, three torques are vanishing, and I have to just take torques due to. I have to take just two torques due to mg sin theta, and that is enough. That will be enough. So this is small r, and this was capital R radius. This is given to us, and we want to find out now. So what will be the distance of t from here to here? I think it will be r plus small r. And what will be this distance? This will be
point A also same only, no, sir.
Which is trying to rotate in which side?
Sir, t in clockwise, sir.
This is in this direction. Mg sin theta.
Anti-clockwise, sir.
Anti-clockwise.
Anti-clockwise, sir, it is.
Anti-clockwise.
And T is
It's in clockwise.
in the blue or arrow side.
And
Blue arrow
tension
side.
are in clockwise, sir.
Clockwise, sir.
Tension is
Tension.
clockwise.
Then what you should
Tension
write the
clockwise,
question,
sir. Mg sin theta.
No, write the question also. I want to get you to
T
get the
into
answer.
R plus R is equal to mg sin theta into capital R, sir.
Yes, so easy because it is already 90 degrees. So
Sir.
T into R plus R quickly. T into R plus R
Equal to mg sin theta into capital R.
R, sir.
minus or plus.
Mg.
This is minus.
Minus only, sir.
Here minus and
Plus
plus.
One is
mg
plus, sir.
sin theta into R
Equals to 0.
is equal
Equals to 0, sir.
or as this he said, T into R plus R is equal to mg
Sin
into
theta into R.
sin theta into R. I
You can
don't
get,
recommend students to follow this. I recommend students to follow directly this, as he said directly now, and suddenly it reminded me that I should also suggest every student to do directly like this.
Yes, sir, because
See, I
both
have
are
two ways to write the
opposite.
force balancing equation. I have two ways to write the force balancing equation. Normal upwards, mg downwards. We can write like this: normal along j cap minus mg along j cap is equal to 0. This is one way of writing. Another is no need to write mg, no need to
N
write
equals
j
to
cap.
mg, sir.
That is second one way of writing. Second way of writing. Third way is just n is equal to mg. I recommend the third way. Reason, and we used to do this only because I know upward force will be equal to downward force magnitude wise. Then I don't have to worry about the signs. Once I do
At
this,
the
then I have to
direction
write sign
they
positive
use.
only. Here also I will do this thing now. If I want to write equation this way, then I will say clockwise torque is equal to anti-clockwise torque. Clockwise
Torque
Torque.
equals to anti-clockwise torque.
is equal to anti-clockwise torque. Whenever we do this way, whenever we write all the clockwise torques on one side and all the anti-clockwise torques on the other side, all the anti-clockwise torques you write on one side and all the clockwise torques you write on the other side, then you are relieved with, you don't have to use the signs in that case.
Yes, sir.
Then
Directly we can write. We can get.
Then directly, then we can write magnitude wise, no need to write sign also, and we can quickly get answers. So I recommend this method only. Use this method now onwards. Clockwise torque is equal to anti-clockwise torque. In that also, then always it will be valid even if there are multiple forces acting. All anti-clockwise put one side, all clockwise put another side. So see how quickly we are getting answer T easily, so fast in one step only. Similarly, after getting T now you can use force balance also. This equation you can use. Now you can use this equation, you can get mu from there. Is it right or not?
Yes, sir.
Yes, sir.
Sir, right on it.
Yes, sir.
Okay.
This angle you try to find out yourself. This angle you try to find out
We'll
yourself.
find,
I'm
sir.
leaving it for you. Mass is given as m, and it is given it is a hemisphere.
Here.
What you want to take it, solid or hollow, your choice. Take it. What do you want to take, solid or hollow? And it's sufficiently rough. Mu is sufficient. Sufficient friction.
Sir,
Time
this
is
was
over?
just about to slide, sir.
Is the time over now?
Yes, sir. Time
Sir,
is
time over.
Evening, sir.
Hello.
12:45, sir.
Yes, sir. In 10 minutes, my class will be over. Just in 10 minutes. Okay, sir. Sir. Okay, sir. Just in 10 minutes, I will call. Okay, sir. Okay, sir. So, sufficient friction. Okay. So we can then I think get it or not. I think we can now. No,
We'll try, sir, this question.
No, I'm
We will
leaving
try,
for
sir.
this question also I'm leaving for you, and this question also I'm leaving for you. In fact, maybe in the evening I can discuss. But if before that, if you get 15 or 20 minutes time, then at least
We'll do, sir.
Take a snapshot. Think about this. Take a snapshot of this and think about this. What we have to find in these two cases, I have to find just forces, friction forces.
Sir, once
Don't
to
know.
previous question, sir.
This question here, bodies in equilibrium.
Sir, what
Find out
we
the
have to
friction
find,
force.
sir?
F and alpha.
Okay, sir.
F and alpha. And in second question also you have to find F1, F2, and that is enough, I think. So this is given small m, radius is given as r. That is enough. And in last question also you can find out F1 and F2, frictions and in this space and friction in that space. Find out these frictions, okay?
When I asked, that is proper highest mark.
This system is in equilibrium. System is in equilibrium. Then in the evening I will discuss these things. Is it okay?
Okay,
Okay, sir.
Can we end it now?
Yes,
when
sir.
yesterday's proper highest mark.
Okay then, okay.
Shiva only highest.
Only, sir.